All right, welcome to the party, pals. So was just doing some final setup here. We'll go through the introduction and then we'll jump into just basic computer components and so forth, starting with some of the different fundamentals. So to start out with, so we always are mentioning the shared mission and values here. So we're just here to break down barriers, foster collaboration and community, working towards a more secure future together. We're all here to learn and grow. So definitely ask questions, answer other people's questions if you know something about it, share resources and anything else as well. Anything that, to benefit the community. That's what it's all about. So our new schedule, especially for the first few weeks, we're going to be going over our schedule each time. So Monday, Tuesday is the hands-on. Today is our Wednesday stream, which is our GRC Let's Get Technical, which we're starting this second one out. Last week, we talked about why we should even worry about technical at all. And then today we're going to go over like basic computer components and how they kind of fit together. Thursday is our primary meeting. So tonight we have a really good one lined up about like what kind of things you should expect as entry level going into information security or GRC, and how to like excel at that type of position when you're just getting started. That's going to be with Fleetus tonight at 6 p.m. Central Time. And then tomorrow we have during our primary meeting on Thursday at 6 p.m. Central. We also have Cynical High Trust talk tomorrow at night. And then Friday are just like AMA. All right. And then I may open up the stage if anybody has questions or would like to come up. Definitely just let me know. I don't have a problem with sending the invite out for the stage. If you choose to do so, you do not have to turn on your video. You could just use your mic if you'd like to. Share your personal LinkedIn. The best place to do that is actually inside of our Discord server. So if you join our Discord server, then you can head on over to our live chat and you could drop your personal LinkedIn page or other social channels. Welcome to the Party Pal Cybercycle. And then just ask questions in chat. You can answer other people's questions as well and so forth, even if it doesn't pertain to exactly what we're talking about. Worst case scenario, we could circle back around to that. And then check out our website, so studygrc.org, in order to check out the other platforms, our resources page, our calendar, which is the most up-to-date location on what to expect coming up. And then we also have some of the different surrounding communities as well. So such as Simply Cyber, which I'm dropping in chat. BDubs has an amazing blog, which drops every single Monday. And then also we got PBO over here as well. And like PBO was just live last night. So Tuesday nights at 9 p.m. Eastern time, he goes live. And last night he was talking about like supply chain family group from the 853. And then with that said, let me go ahead and transition on over here. And then I'm going to go ahead and get my presentation pulled up as well. All right, let's get started. Let me see if I can make this any bigger here. I may just try to export this real quick instead. I think we can go ahead and run with this portion here. So I'm going to go ahead and move this around a little bit. If you guys have any questions, definitely drop that in chat. Here in a moment, I'm going to go ahead and start with the presentation. Our primary goal today is just to go over some of the basic components and so forth. Welcome to the Party Pal, not only IT. Out of curiosity, could you give a little bit more information on the name, not only IT? What else do you do? Just curious about little information sharing. All right, so like I said, we're going to be starting out this series, starting from like some of the very basics and fundamentals and then working our way up. Eventually, what we'll be doing on Wednesdays is going to be like actual rooms, maybe try Hack Me or Let's Defend, and actually going through more technical hands-on stuff as well. So to start out with, I wanted to go ahead and showcase this photo. So if you look at the very first slide here that's up on the screen, you'll see one thing I hate about this is it just keeps showcasing that. Oh, engineering. Welcome to the party, pal, AMK. Let me go ahead. I think we could just make this look way better if I just import this. I'm just going to go ahead and get this imported instead because that just doesn't seem to look good enough there. Mechanical engineering or like structural engineering, just out of curiosity. I'm just prying for information at this time. I think that's a really good combination though. All right, now I can go ahead and get this imported here. And then we'll see this pop up in real time. And you don't have to answer if you don't want to. I honestly, I've seen you around the community and so forth and whatnot, and generally kind of curious to learn a little bit more. I believe you mentioned the engineering part to me before. Why does my room look like a Japanese room? What does a Japanese room look like, AMK? So I could make it a little bit bigger here. So here in a moment, this presentation will load in and then we'll go ahead and get started with it. There we go. All right, so let me go ahead and move back over to this. Welcome, Viper. All right, so today we're going to be going through this presentation here and just going over the basic computer components. If you guys have any questions, definitely drop it in chat. I'm going to try to keep up with it as well as I can. I wanted to showcase this image first of all, because this is what I believe most people are thinking about when you say computer parts or computer components. They see this green board full of different components and stuff thrown onto it, along with, labels that don't really make much sense to the average human being. Now, knowing that not only IT comes from engineering probably makes way more sense to them. However, this is not what we're talking about. So let me go ahead and move this on over. So this is more so what we're talking about. So we're going to go through each one of these components here and just talk a little bit about how they fit into our computer devices and then also other things that connect to them. We're not going to go to the fine grain where, we're talking about the pieces that are non-removable. That's a completely different story. So when you go off and you build your own computer, for an example, these are the types of parts that you're typically looking for. Starting with the motherboard itself, you need a power supply. You may need a graphics card. There's both an SSD and an HDD, so solid state drive, and then actual hard drive, CPU cooler, a CPU, RAM, and so forth. And there's a lot of different components, and it may seem a little bit confusing off the bat. But we're going to go ahead and go through it here today. And then hopefully in the near future, we'll actually go through and do a hands-on type of thing where we actually assemble something on video. Modern lights and compacted like an anime. Minimalist decor. That's kind of interesting you guys say so, because I am very minimalist. All right, so the very first part here, so we're going to talk about the motherboard. So the motherboard is what connects all of the components. It comes in multiple different sizes. It provides a couple different examples here. So ATX, micro ATX, mini ITX, and there's a couple other options as well. So they come in different sizes. That's what those different things mean. The ATX, micro ATX, mini ITX, for an example. Your traditional motherboard itself is most likely going to fall into that ATX or micro ATX. It kind of depends. So that's normally what you're going to see, but you can also do smaller builds, which would be like the mini ITX, which may only have one slot. So if you look at the image on the left-hand side, you see those silver slots. I don't think I could select anything on the screen here, but you see those silver looking slots there. Those is typically for your graphics card, but there's other things that can go into that. And the mini ITX may only have one, if not any of them. Yes, it probably is some type of knockoff of the NZXT motherboards. So this is AI generated, but it gives you a really good example of a non-branded one. And there's a lot of different brands, and it's interesting you actually state that because like Gigabyte's really popular, Asus is popular, MSI. There's so many different brands that are out there, and they also vary in prices. Another big factor is the chipset itself. So let me go ahead and pull up, let's see here. So Asus motherboard. So the chipsets make a difference as well. And the best way to think of a chipset is going to be like the nervous system. So you have the CPU, which we'll talk about in a moment, which will go on that little centerpiece right there that has like a bar on it. That's what your actual CPU is going to end up going into. Now I'm going to go ahead and I should be able to transition over to this too. So then I want to showcase this as well. So this is just the page for Asus's ROG motherboards. And so you see that how this says Z790. So that's going to be like a top of the line, you know, pretty good one. And that's going to be the type of chipset. And what I was hoping to see here, yeah, so let me zoom in. So on their website here, you could see chipset. And so the chipset is like the nervous system. So that's what's communicating with all of these other components and so forth. And it does play a pretty significant factor. And so you could see that there's chipsets for Intel along with different numbers. The higher the number, typically the better it is. So the Z90 is going to be better than the B660, for an example, or the 590. Now you do have to make sure that whatever you get, the socket itself for the CPU, which we'll talk a little bit about later, will fit, but then also the brand itself. So like AMD 670. And you could see that Intel is the only one that has the 790 here, it looks like. But AMD does have an 870. And so those are the different chipsets. And that's like the nervous system that interconnects and communicates with everything. It's just one of the other things to keep in mind. You can also see here the form factor. So we have that ATX, micro ATX, and mini ITX, which are probably the most common ones. And so those are the different sizes of motherboard itself. Most of what you will come across are going to be that ATX and micro ATX. So those are going to be the two most common. And then you also have what's called an extended or an eATX, which is going to be oversized, even bigger, which then you really need to make sure like the case you get is full size and so forth as well. Now, let me go ahead and transition back over to this slide. Yeah, and if you guys have any questions whatsoever, definitely drop it into the comments or join our Discord server, throw it in the live chat as well. I'm going to keep an eye on that as close as possible. So some of this, I'm going to try to keep this as fundamental as possible, but I definitely understand that this is going to be a little confusing to somebody who's not very familiar with it. It's just like the sizes, like ATX, micro ATX, mini ITX. Like, why couldn't they just do, small, medium, and large, and then extra large? I don't know the answer to that. Hopefully things change in the future, right? And you also see the socket here. So CPU socket determines CPU compatibility. And that's what I was talking about a moment ago, is you need to make sure that the processor you get, whether it's AMD or Intel, which are the two biggest ones, it's compatible with that, which we'll see on this, I believe, the next slide here. So then the brain of the computer itself is the CPU. So this is what I think gets the most highlight, and maybe the most amount of people will be familiar with, is the CPU, so central processing unit. There's really three different things. I have two of them listed here, but there's really three primary things that go around with a CPU. You have your core count, which you'll hear things like a dual core or quad core or hex core and so forth. And then underneath the cores, then you'll have threads. And so, like, for an example, my machine is an 8-core with 2 threads per core, which means that I have 16 total threads. And I may actually showcase like my my task manager here to actually show you what that actually kind of looks like a little bit more. Let me see. So I'm actually going to take a screenshot here if you guys want to hop into Discord. And I'll actually take a screenshot of like my It'll be easier to just drop a screenshot than anything else. So I'm going to go ahead and drop that into the live chat on our Discord server. And what that kind of showcases is it says, you know, one socket, meaning there's one CPU, and then 8 cores, and then there's 16 logical processors, which is the thread count. So 2 per each. Now, it really depends on what you're doing. Like for an example, like my mobile laptop that I take everywhere, that technically is 8 cores, but it only runs, I believe, at like 1.6 gigahertz, whereas the computer I typically stream from goes all the way up to like 4.6 gigahertz. And that's what this clock speed is. That clock speed determines how fast it goes, how quickly it can do different logical calculations. And that's really what it does, is your CPU is actually doing math. It's the brain of it. And so like it says here, fetches, decodes, and executes instructions, performs calculations and logic. Oh, welcome to the party, pal, Heavy One EUW, coming in from Germany. Welcome to the party, pal. And so, especially when this is what I was saying is this probably seems to be the most common thing that people may have heard about, because when you're looking at new computers, you're like, oh, how many cores does it have? Or what do I need to get, and so forth. And so it really depends on what you do. And it's just going to completely advance more and more and more. You know, back in my day, per se, you know, a quad core was good for gaming. Nowadays, you see way more than that. So most of the people that I know are probably running at least 6 cores, if not more. It just depends on what its purpose is for. But like I said, I also have, you know, like a cheaper laptop that just runs at a really low speed, but it still has 8 cores, which works absolute wonders, and it's light and portable. And so also the image here on the right is like an example of a CPU, and I'm going to transition. So you see the little bracket thing, the socket itself that it's inside of. And I'm going to show another photo of a CPU in a moment. But on this photo of the motherboard, you'll see the same shape of socket. And so there's different types of sockets. Right now, the most modern ones, I'm not sure about Intel, but I know AMD is like AM5 is the newest socket version. And so when you're purchasing your motherboard, you want to make sure that the CPU, the processor that you purchase, will fit into that. And it's typically going to be a certain type of Intel, which is like an LGA type of socket. It'll come with a number afterwards. And then also AMD would be AM5 for the latest models, or AM4 for the previous generation. When you purchase that processor, it'll clearly state that. Another major component for different computer systems is going to be RAM. One of the really interesting things is that now we're getting to the point where, especially in, you know, like mobile devices and then also laptops, a lot of the RAM is actually soldered to the motherboard itself. So it's built in. It's not really made to be upgradable or replaceable or otherwise, which also it has pros and cons. So definitely a repair issue. However, it does typically have increased speeds and so forth. So I do foresee, unfortunately, in the future, you know, 5-10 years from now, we may not even be able to do much with the RAM itself. But in the meantime, we can. And on the right-hand side, you'll see an example of an image. So it comes in various sizes, of course. You typically have a laptop size RAM, which is a little bit smaller, which I think I actually have one. Yeah, so like this is a perfect example. So you see some of the different images there on the right-hand side. Well, those are primarily for desktops. Those are larger. Now this here is for laptop. So it's just a different size. Oh, it's gonna mess with me here. But you'll see here, this is exactly what a RAM stick would look like. And so it's random access memory. So nowadays we have gigabytes. Back in the day we had megabytes, but the technology itself hasn't really changed too much. They just made it, you know, more in the same form factor for the most part. And then you also have megahertz. So the megahertz, so like this particular one, if I look at the package here, is 16 gigs. So 16 gigabyte, which means that, you know, that's a form of storage and so forth. And then this one runs at a maximum of 5,600 megahertz, which is just how fast it goes. And you also have different sizes. So if you guys can see this, you can see that this is a DDR5. So, and that is like the latest version, you know, type of RAM itself. Kind of like with the sockets, you have AM4 for the previous version and AM5 for the latest one for AMD processors. This is a DDR5. If you guys have questions regarding this, definitely let me know. But this is another thing where when you're picking out these different computer components, you just need to make sure that it's compatible. And typically you'll start out with something like the motherboard, and it'll dictate and actually state like what it is. Does it take DDR5? What speed is it capable of? And you'll just have to look at the specs for that when you pick out the component. And then that will help you pick out what other components you need to get for that. And each system is going to be different with that. Nowadays, I would probably not get anything below 16 gigabytes. Let's see. Fleeta says that they had a pile of RAM, but can't quite recall where he put them. Yeah, I must have lost all the memory, all his memory. Yeah, I had a whole box full of old like DDR3 that I ended up like scrapping. I had no purpose for it ever again. Oh, it's an ongoing joke too. So I walked down the street where the houses were numbered 64K, 128, 256, 512, and 1 meg. That was a trip down memory lane. Yeah. And so that's like back in the day, you know, like I remember at least in my time, like 512 megabytes in the same form factor here. Oh, I guess it would have made it a little bit easier if I probably made myself a little larger here too. So, you know, this is the laptop sized one as compared to some of those other images there. And then I'll showcase the actual package as well. There you go. So you could see right there, like the section that says 5600, that's going to be the speed of it. And it's the SODIMM. And it also says DDR5 on it, 16 gigabyte. And if you guys ever have any questions, like you guys want to do your own computer build or otherwise, one really great website for that I like is just to pick out the components. There's a website called PC Part Picker. And this allows you to go through, it's a free service. I probably wouldn't purchase through their affiliate links, but you can at least pick out what parts you want. And it'll help you with compatibility as well. That's a really good resource there if you guys are ever interested in building your own computer itself. Let me go ahead and transition this back over. And so like when you load up a program, for an example, when you start your web browser like Brave or Edge or anything like that, then what it's doing is it's loading some of that memory, some temporary memory into your RAM itself to keep it running. You know, what websites you're visiting, you know, caching images and so forth onto your RAM. There's a lot of other things that it does too. Your system processes as well. You could do temporary storage and a lot of other things with it. That's for one of the biggest reasons for RAM is because it's extremely quick. It's a lot easier than storing it on your storage device. There is another method that's called swap storage, which we won't really get into today. But now you'll find two different types of hard drives for storage. So SSD, which is becoming the go-to nowadays, especially considering how much cheaper it's become. And then you also have an HDD, so hard disk drive. And on the right-hand side is a side-by-side comparison. So an HDD is mechanical. So it actually has a spinning disk inside of it. It does emit noise. It has moving components, which also increases its failure rate and a lot of other factors as well. However, SSDs also have some downsides as well, such as like a read-write limit. So like after you write to that same partition so many times, then it may give out, and they wear down. So they are solid state, so it doesn't have moving components, but it's silicon. It's still holds that memory inside. And there's a really great video on YouTube that I'll drop as well that actually shows you how memory works, how solid state memory works, how it actually, puts into the different sectors. Let me see if I could pull that up here. I'm pretty sure I have that bookmarked here somewhere. And then some of this is just a couple different examples here. So like an HDD typically will have lower speeds because it's mechanical. However, it is cheaper. So that is pretty much all we had 10 or 15 years ago. SSD was not very commonly used because it was so expensive. But even nowadays, you'll still see that utilized in certain practices. Like, you could set up NAS drives, so network attached storage devices, and it's really great for setting up RAID, where you have backup hard drives. And for the price of the storage itself, and especially if you could do a RAID setup that backs up and so forth, it's actually a really good option. And you'll also find the HDDs in a very high capacities, like 16 terabytes, 24 terabytes, which is just crazy amounts of storage on a single drive itself. Cybercycle got me in the past as well. Oh yeah, I haven't even looked at Newegg. So Newegg is a website that's pretty well known for buying computer components as well. And not only IT also states that they have a PC builder. It comes in really good handy if you could find a tool like that, just to make sure for compatibility. But also, if you guys do actually go through that process, definitely drop in chat on Simply Cyber or Study GRC or wherever. There's plenty of people in the community willing to help, make sure that everything's good with it. And so now there's benefits of solid state drive as well. So it typically is a little bit more expensive, although there are cheaper options nowadays, which just makes it make sense a little bit more. It is way faster than the mechanical HDDs. So the standard mechanical hard drives are great and everything else, and they still work pretty quickly. However, if you're gaming just for like quick boot times and so forth, like we're talking like 4, 5, 6 times quicker on the SSD. Oh, Cybercycle's now talking about a whopping 1 megabyte RAM. That was way before my time, but yeah, I remember like 512 megabyte. And so this gives you an example on the right-hand side for the image here as well. And so this is what your operating system is actually going to be installed on. This is what all of your apps go onto and so forth. All of your storage goes onto these drives here. And typically you'll only have one drive for a system, although there are methods to go through and set up multiple. So like on a desktop, for an example, you may have 2 or 3 or 4 of them. You just have to make sure that you have a motherboard that's compatible with that. You have to set that up a certain way and so forth. But most systems you'll see with just one of these. And most of the time you're going to go with a solid state. I would probably say what's becoming most common nowadays is a 1 terabyte, which is 1,000 gigabyte solid state drive. That's probably what I see most commonly. And one of the other things before I do skip here is I think it's also important to mention like the M2 drives. So especially nowadays, yeah, here's a perfect image of it. So I'm going to drop this. So I'm going to drop this link right here, and I'll show you guys this image as well. Let me go ahead and transition this over again. All right, so I dropped the link to this website here, and they have this image here. So the previous image that we were looking at is a standard 2.5-inch solid state drive, which is on the far right-hand side of this image here. But then you also have various other sizes of solid state as well. These M2 come in a couple different sizes as well, which are the 2 in the middle. Those are becoming way more popular. And I can also show you an example on like a motherboard or otherwise of where that would fit in. Let me find a good image for that, because this is becoming way more popular than having an external hard drive. So typically you would have the one that's on the far right-hand side that would plug in, but it would be separate from the motherboard entirely, like a cable would be ran in between the two. Whereas these ones in the center are going to be, you know, an M2, I think it's like 8840 or something along those lines. They have a Gen 4 and they just recently came out with a Gen 5. And I just want to showcase where that would kind of go as an example. Okay, here we go. So then I'm going to go ahead and move over here. And so let me zoom in a little bit. So you can see here how they have an image of like the end of it. And so you can also see on the tag here, it says 128 gigabyte. And it also shows the slots on it. And so you want to make sure that the slots line up. And then on the newer motherboards, you're typically going to have, and you'll see this in the description and specs for the motherboard, where it states, you know, M2 Gen 4 or Gen 5 compatible or whatever it is. And you'll see where you can actually slide it into a slot just like this on the right-hand side. So let me double check that you guys, yeah, you guys can see that pretty well. And so this is going to be, you know, very, very popular. If you're buying a newer system, if you're buying a newer components and so forth, I'm pretty sure all of the motherboards nowadays have these slots for the M2 drives now, SSDs. It just reduces the cables that you need to use. It's faster, lot less issues there. But yeah, that's why I feel it's important to mention this portion as well. So if you are building a modern system, definitely take a look to see if it has the M2 and what version it has, and then try to find one of those. And so like if I were to go off and build a system now, I would get a 1 terabyte, you know, M2 SSD and just make sure that it's compatible with that motherboard. And then I'm going to go ahead and pull this back up here. All right, and then like another component here is going to be the GPU, so the graphics card. Now, this is not always necessary. So if you're just browsing the internet, if you're not really playing any games, if you're not running like more demanding applications that would require a graphics card, then you may be able to get away with having that integrated into your actual processor. So there are processors, the CPUs, that do have graphic card capability integrated into it. Now they are limited, which is a very important thing to state because it's not a replacement of a graphics card per se. However, you could typically get away, and like with AMD, they'll put a G at the end of it. And so it's not going to provide the full capability as a completely separate graphics card, but you could still run your web browser. You could still watch YouTube videos off of it and so forth. You may be able to do some lower end gaming or otherwise. If you are going to do gaming, if you're going to do video editing, if you're going to do more intensive activities, then you most likely have to get a graphics card as well. And this is where a large portion of the price typically comes in as well. So you can get some of the graphics cards, some of the lower end ones may be like $80, $100, but then like the newest generation for the GeForce, the NVIDIA GeForce ones, they have the 5080, which is like $1,000. And the 5090, which is like $2,000, is their latest lineup. So the prices definitely increased big time. And when you're doing like a gaming setup or otherwise, the graphics card typically is a good chunk of the overall price. And in this image here, you'll just see a whole collage of different types of graphic cards. Some of these are pretty old and outdated, but you'll also see some higher end and some lower end ones here as well. Depending on the system, if your processor does not have integrated graphics, you will most certainly have to get a graphics card itself. Yes, Cybercycle, that 5090. The low end for the 5090 is running $2,000. And it's already becoming a whole scalp deal as well. So I'm already seeing listings on eBay for $3,500. Yeah. Although it is an absolute beast. I believe it has, I think the default for $2,000 comes with 32 gigabytes of memory, of RAM in it. And so the graphics card is typically separated because it's specially designed to do the processing power for the graphics. And so it also has a gigabyte rating for the RAM. It has its own built-on RAM itself, which you may see some that are only 2 gigabytes or 6 or 8. I believe the graphics card that I have, I believe it's an 8 gigabyte. So you have to maybe do a little bit of research, look at that. Maybe if you want to go with gaming, then you want to look at what their recommendations are. Like on Steam, for an example, they'll provide recommended graphic cards for, minimum and recommended, which would be a really good comparison on what you may need. Yeah, and so the 5080 is running I think it's $1,000 to $1,200, and then the 5090 is like $2,000. So just for the graphics card itself. But still, you can get a decent graphics card for under $200, but it is typically a good chunk of the price for building a computer. And again, if you guys have any questions, drop it in chat, drop it in the comments. Go ahead and join our Discord server and so forth as well. So then another component here is going to be the PSU, so power supply unit. And this is a perfect example of what this looks like. Many of you have probably seen this before, and you'll see this plug on the back of the computer itself. I'm still trying to highlight it, even though you guys can't see my cursor. But you'll see next to the switch right here on the left-hand side of the image on the right, that there's like a plug right there. And that's where the cable that you'll actually plug in and then plug into the wall goes into. All of those wires on the right-hand side of the image, nowadays there's also power supplies that are called modular, which means that you can actually, it doesn't have a whole bundle of cables that you're not going to use. It'll actually come up with cables that you plug into it, so you're only using the cables that you actually need. It's very, very useful. Now you'll still find these, especially the lower end power supplies, that will just have a bundle of cables on the end of it. Now, some of the big things when you're picking out the power supply is figuring out what kind of wattage do you need. That's when you have to look at the fans that you have, the processor that you have. You have to take a look at, how much wattage range are you going to be utilizing, especially like with the graphics card makes a big difference as well. And that's another reason why using something like that PC parts builder, because it will give you recommended power supply. And you always want to kind of overshoot that a little bit as well. And so you could find like the power supplies in like 200 watts, 250, 400, 500, and then like higher end builds are going to be running 1,000 watts, 1,200 watts, 1,500 watts, and so forth. I feel for a pretty decent setup, you're probably going to be in like that 600 to 800 watt range for like a mid-tier setup. However, again, results are going to vary, which is why just checking the compatibility and using one of those tools or asking, the community itself for some assistance with that if you're not too familiar with it. It also comes with different levels of efficiency. So you'll see things like 80 plus copper, 80 plus gold, 80 plus platinum, and so forth. That's just the efficiency level. So when it's running at 100% power, how efficient is that? So if you have 1,000 watt power supply, which is pretty big, unless you're running a higher end setup, unless you have that 5090 for an example, you're probably not running over 1,000 watts. But if you are maxing out at that 100% capacity on your power supply, if you have like the 80 plus platinum for an example, then only like 5 to 10% of that power is actually not being used. It's going to waste. You're always going to have some of that power go to waste, but that's just how efficient it is. And then also, like it also mentions here, that module section as well. So if you have the ability to do so, I personally really like Corsair. So Corsair has a lineup of power supplies. I think during Black Friday, I picked one up like 650 watts. It was like 75, 80 bucks. And it is also modular as well, which allows me to plug what cables I need in. But definitely take a look at that. And then we also have different cooling systems as well. I got to pull up a couple examples for that as well. Liquid cooling is going to be for the higher end gaming setups and so forth. If you're running top of the line processors or graphic cards, then you may be looking at liquid cooling. That is a very complicated process. There's a lot of things that could go wrong, especially for your first computer build or otherwise. If you are going to go with high end and you do need to do the liquid cooling, I highly suggest finding somebody local in person that could assist you with that, just because so many things could go wrong with that. It's typically not a very straightforward process. And I don't want, anything to go dramatically bad for it. With that said, though, there's multiple different options with that. You could do some really cool things with liquid cooling. I think that's probably the most common types of photos that you see is the liquid cooled. You could do hard pipes, you could do see-through pipes, you could do all kinds of different really cool things with it. But that's typically for the higher end, especially if you're going for like mid-tier. Like I personally wouldn't use any liquid cooling unless I'm doing top of the line. Yeah, and so like Jeffrey Johnson says, don't want to do it, LOL. Yeah, I don't suggest the liquid cooling. The only circumstance I would do that is if you are running a top of the line processor. Anything above the top of the line, then I wouldn't even touch the liquid cooling. There's just so much involved with it. You also typically have to go through and like flush the system out and change the water out, the actual coolant every so often as well. It's not an easy thing to handle. What you'll typically have though, 99% of the time is going to be the air cooled, and which is just using the fans and heat sinks itself. And that's what you'll typically see. Let me pull up a couple examples here. So, I am pretty biased regarding Noctua personally. So I'm going to go ahead and pull this up. Let's see. So like this is some examples of CPU coolers. All right, and so like right here on the right-hand side, you'll see this one. There should be a couple other examples here. But you can see here, so at the very bottom base of this is where it would actually go on top of your processor itself. And so this is what the D15, yeah. And so this is like a higher end cooler. You most likely won't need this, but it does work really, really well. But so it's going to attach to the top of your processor itself. Typically, you'll have the actual thermal paste that goes in between the two, which you'd never want to use too much. Definitely watch a video on it, especially if it's your first time doing a build or otherwise. You want to be very careful with the thermal paste. There's a certain pattern you want to put out, and you don't want to use too much or too little. But it's going to go on top of your processor, and then you see these fins and everything else here. These are heat pipes that come out, which are designed to actually take the heat and move them upwards into these fins. And then this particular model also has fans built onto it to take that heat away from the metal itself. So this is just one example of that. There's a couple other different models. This comes, a lot of different brands that make the CPU coolers. And then there's also other ones as well. So like this would be an example of a fanless, take of it. But there's so many different brands and styles and so forth. But that's the basic understanding there where it connects to the top. Now, that's not the only type though, too, because let me pull this up over here. So, because the CPU cooler is only one part of the process. So that's probably what most people think about when you say a computer, cooler or otherwise. But nowadays you have a lot more than that. So for an example, this is one of the Asus motherboards. And so if you take a look at this, then you have like some of these aluminum components that are on the top and towards the bottom here as well. So these like aluminum colored components are heat sinks, which are designed to help take the heat away, disperse it out, and just keep the temperatures a little bit lower. How effective that is, You know, who knows? But typically you'll also have fans inside of your case, which we'll talk about cases in a moment. So this is just supposed to give you a little bit of an idea of how all of this comes together. You could see on this one as well. So like right dead center where it says Republic of Gamers, that is a heatsink that appears to be going over where one of those M2 drives that I was talking about would go. And that's just another example of part of the cooling system itself. So a lot of the motherboards nowadays also have built-on heat sinks that are built into the motherboard itself. Here's another really great example. And the more heat sinks that it has, typically the higher the price. You'll see some of the lower end boards. If it doesn't have the heat sinks on it, that doesn't mean it's a bad thing. A large portion of this nowadays is just for style and looks. So yes, it does make a little bit of a difference maybe, but it's not a make or break. So you'll still find motherboards that don't have any of these heat sinks on it either, or minimal amount. So like here's another good example where it does have some heat sink on it, but not massively, not covering half of the board. Or like this one here. Here's another great example. So this is probably a lower end, cheaper board, which would work still just perfectly fine, but it doesn't have, you know, half the board and the whole back section of it covered in aluminum or heatsink. All right, let me go ahead and pull this back up over here. So like CyberCycle mentions pricing regarding the heat sinks and so forth. So I've noticed that the classic fan-based CPU heat sinks are the near/closing into similar same prices as AIO water coolers. And so that may be true to an extent. I think it kind of depends on what type of build you're going to be doing. Largely just because you know, like Noctua, I would consider a very premium brand, and yet you could get some of their CPU coolers for low to mid tier for like $40. I know that you can get some of the AIO coolers for, you know, $80, $120 range, which like that D15 cooler that I was showing from Noctua with the two fans on it. I think that one ranges about $115 to $120 roughly. But also like one of the big things that I just want to mention there is that even if it is the same price range, I would stay the hell away from water coolers unless I had to, just because of the added stress of that. I wouldn't want to have to be flushing that out and changing out the coolant and taking the risk of some type of hole or something going wrong with that at some point. I feel too many people just throw in the liquid cooling because they think it's neat and then they forget about it. So yeah. Now, if you are doing a higher end setup, then they do typically recommend, like if you're running like what is it, a 9950X or something like that, then AMD, which is a type of processor, then AMD does actually recommend liquid cooling. I've actually talked to people who, which is understandable too, because like they'll get a processor that's like, you know, like low tier, mid tier, not too powerful, and they'd still insist on, oh, I'm going to do liquid cooling. So yeah. And so CyberCycle mentions settling on the AIO due to noise and longevity. I think that also depends on brand too, because like I run Noctua for an example, and I don't hear anything. But also I like, there's a lot of different things that go into it. And that's still, you know, could be more expensive than the IO. And mentioning Arctic as well. So, and then there's also multiple different brands. So like there's Arctic, Cooler Master is a popular one. Corsair is another one. There's so many different ones as well with that. Yeah, and see, like that's the whole thing, is that liquid cooling looks so cool. That's probably why most people go with liquid cooling, is because it looks cool and it's good to talk about. but its true effectiveness. And like another thing to note out too is a lot of people who do liquid cooling oftentimes will do overclocking, which is when you're actually like going into your BIOS and you start actually increasing the speeds, those gigahertz and speeds of your processor and RAM and so forth, and you start configuring that to a higher degree than they're designed to do, which would be another reason for liquid cooling when you're pushing the actual hardware beyond its original. Let's see. All right, and then, so now moving on to cases, the protective shell. Again, so just like with motherboards, many different sizes out there, all the way from tiny little cases, which like on the right-hand side, you'll see a case that was designed with a mini ITX. And then on the left-hand side is more of like a mid-tower. So that's gonna be like a standard ATX board. And again, with the motherboards themselves, you'll typically find the ATX or mini ATX. So those are going to be the most common. And then you have a small motherboard, which is going to be that mini ITX. And so those are just the different sizes: small, medium, large. And then you also have an extended ATX, which is going to be the very large or extra large. And some of the different key things with the cases that I would just watch out for is just make sure that it's going to be compatible with the motherboard. You can cheap out. I see a lot of people cheap out on the case among everything, but you want to also make sure that, you know, you have fans. Like I've seen some really great deals for some cheaper cases, but the benefit is that, yeah, the case may be, you know, $65, but it comes with 6 fans. So especially running a setup on a budget or otherwise, that's an amazing deal, because also fans add up quickly. So that's also something to take a look at. And then there are a couple other compatibility things to look out for. Like even the power supplies do come in different sizes. Most of the time when you're doing a desktop build, you're going to be getting that ATX size processor or power supply. And then also your graphics card. If you are especially doing like a mid-tier, then you also need to make sure. So typically when you're looking at computer cases, it will state how many millimeters in length of the GPU it can handle. So like a very common one would probably be around 300 millimeters, which is a pretty good size graphics card. But that's just another thing to keep in mind. And then especially if you're doing a smaller build, like a mini ITX in a smaller case, then you have to take even more precautions and make sure, oh, okay, do I have enough height above the motherboard to the side of the case, you know, for that cooler and so forth as well. So then you start getting into like, okay, how is this all going to fit together? There's also a lot of different input devices that I'm sure we all use on a daily basis. Keyboards, mice, and beyond. Microphones, web cameras, the list goes on and on. There's different gaming pads. There's all kinds of different, we're also using like controllers nowadays over Bluetooth that connect to your computer. A lot of different things. So those are typically going to be, nowadays it's moving over to like Bluetooth for wireless. But also traditionally, or with some of it now, you'll still be using USB. So I think that side may be the most familiar aspect for a lot of people. You know, typically when like I go through to do a computer build or otherwise, which I don't do very often, but I've done it a few times, I just try to make sure that there's going to be enough ports, there's going to be enough USBs or otherwise to meet my needs. Like one of my biggest issues now is a lack of USB-C. So both my web camera and my security key use the 2 USB-Cs that I have. So the next computer build I do is going to have more USB-Cs. Yeah, thanks for hopping in, B-Dubs and Cybercycle. And so looking at like the different devices that you're going to utilize, you just need to make sure that you have those ports on the device itself. And then we also have different output devices. So that's going to be like your displays. Your displays are typically going to plug into your graphics card itself, but that may change as well. So if you don't use the graphics card and you get one of the processors with integrated graphics, which are going to be limited, then you may just plug that directly into your motherboard itself on the back side. There's a lot of different things that go into this as well that you could do a really deep dive on. But even printers, I think, are becoming less common, but that's could still be a thing. A lot of the printers I see now connect to your Wi-Fi network, and then you just print through your network there. But you could look at, like the resolution. Do you want 1080p? Do you want 4K? If you're doing gaming, then you may be looking at that refresh rate. So a typical refresh rate may be between 60 and 140 hertz, which is just how fast the images refresh on the screen. They do also make monitors. If you're doing a higher end setup, then you may be looking at monitors that have a 240 hertz refresh rate or otherwise as well. Or if you're into graphics and so forth, then maybe the color accuracy is an important factor. Now the networking, that's going to be one of the big topics that we talk about next week. So next week, we're just going to talk about like the wireless cards, the router itself, some of the different base settings for that itself, how to, test some of that out as well. But the key thing here is that you typically have a network card, whether that be wireless or Ethernet, which I have one of these cables here too. So like looking at this, you're probably a little bit more familiar with it. But so this is going to be an Ethernet cord. So like a Cat5 is what they would call it, which would typically plug into your desktop or even laptop or other devices if you're wired in. Or you use wireless, which I think is way more common now. And then that's going to just connect to your router, which then plugs into a wire out of the wall or a modem or otherwise, and connects to your Ethernet service provider. So whoever you get your internet through. And definitely check out next week, because next week is all going to be about networking. I have a nice little diagram for it, along with a couple of the different... if you guys want to go through it now, I could drop the links for it, because like TryHackMe has some rooms for it as well that are really, really good. Now putting it all together. So this is just kind of a step-by-step. So like I dropped that PC parts builder. So you select your components and make sure that they're compatible. You get all of those components together and assemble the system. And then you have to install the operating system, so the OS. So most of the time you're going to be installing Windows, which you can like go on Amazon or otherwise and get a USB drive for it, or you could download a digital copy of Windows and to be able to install that when you first boot it up. So it's going to be a little bit different for each system, but that's also where community comes in. So if you're not familiar with installing an operating system, then you could just, if you can't figure that part out, typically you'll have to click one of the F buttons at the top of your keyboard, maybe F12, F10, F9, it depends on the system itself. And then you'll be able to boot the OS USB in order to install Windows. And then you would typically go through and test the system, make sure that everything's running properly. Some of the common issues that occur may be, your CPU starts overheating, so your processor heatsink is not actually working at full capacity, and it starts overheating because it doesn't have a good seal with the CPU cooler, or like your memory, your RAM itself may not be running at the speeds that you expected. So there's a lot of other things that go along with that as well. The networking portion is honestly my hardest subject. So there's so many different concepts and things that go along with networking that's just confusing. And so the fundamental portion is great, but I may take the Net Plus just to get it out of the way. I absolutely struggled with even trying to wrap my head around like the TCP IP model and so forth. So it's definitely a common issue. a struggle point. And then if you guys have any questions, definitely go ahead and drop that in chat. Otherwise, we're going to go ahead and end the stream. Definitely hop into the Discord server if you haven't already. That's the best place to catch us outside of the live streams. Now, later tonight at 6 p.m. Central Time, so in about 6 hours from now, we will be live streaming again, and Fleetus will be talking about like some of the different things that would be expected of somebody entering the industry, in their first entry-level role. Different maybe tips or tricks on how to excel at that, and questions to ask or things to look into and so forth as well. And that's in about 6 hours. And then tomorrow night at 6 p.m. Central is our primary Thursday meeting, which is going to be about high trust. So cynical high trust. So definitely check those out. And then I'll stick around just for a moment if you guys have any questions or otherwise. And then here in the near future, I hope to, we'll actually go through and do some type of build as well, which I'll attach to this video. I'll put that link in the description at that time once we go through and physically build something. I have this desk behind me that we'll be able to move the camera over to. There's a lot of other videos that are already online for that as well. And yeah, one of the biggest key takeaways here is that there's so many different compatibility issues and different nuances to it, that one of the best things to do is use something like that PC parts builder, and then ask the community. Just drop it in chat and be like, hey, this is what I'm looking at doing. What do you guys think? Is this going to work? Or do you think these are compatible, and so forth? So I hope to see you guys later tonight, and definitely our big meeting, big primary meeting tomorrow night as well. And you guys have a great rest of the day. I'll catch you guys.